Hey guys, welcome to this video. Today we'll be looking at how to set up the dependencies in environment for running the backend generators using the open source cloud. For this, first we need to land up here in this particular URL page, which is the Git repo of the open source DB template project. And within this project, we have to make sure that we are on version 1.2 RC branch. And once we are here, we could then scroll down a bit until we see the README file, and we scroll down a bit more. We have the requirements under the instructions for running section, and here we see the first requirement as a Linux system, and preferably it could be Ubuntu 22.04 LTS version. So in theory, this tool should work with almost any Linux-based system, but we would prefer this because, yeah, that's what we've been mostly testing this tool on. So the easiest way to get it if you're on Windows is to set up Windows subsystem for Linux, like how I did. Okay, I'm just gonna clear the screen. It's like test. Okay, yeah. So this is how this is how the shell should look like. After you have set up WSL for Linux, there's also this small WSL recipe that's also posted here in this Git repo page. If you would like, you could have a look at it, or even if you have dual booted it or have a separate system with only let's say Ubuntu running on it, it should all work fine. So assuming you have already set up the Linux, um, as a just to be on the safer side, you could always start with doing sudo apt update. Uh, Update, and once this is finished, you could also do sudo apt full upgrade -y. Okay, so this is good. And since we have sorted out the first requirement, let's move to the second one. The second thing here is Python version 3.10, which is like the minimum version. If you have a latest version than this, then it's perfectly fine. And also the Python 3 pip. So we can go ahead and install this again. Sudo apt install Python 3 and Python. Okay, I have already tested this entire recipe once, so for me, uh, there was no need to install anything separately. But for you guys, it should take some time. You should fetch some stuff, should download some stuff, and then it installs it. So yeah, it's if you see something different from what you see on my screen, then it's perfectly fine. So once this is done, I would also prefer that we install all our Python packages in a separate virtual environment. And to set up the environment, there is another separate recipe here, which we can quickly go through. So here we see that we have already done, we already did this. And now it's time for us to just copy these commands in I mean, it's just easier for us to copy the commands which are in codes, and we just yeah, copy. Okay, just copying this, and then we paste it. And again, in my case, it's already done, and so you can just and it's very straightforward. You could just uh, copy the commands and execute the ones here sequentially. Like first copy this one, paste it, run it, and then copy this one. So basically, what we are trying to do here is to create a separate directory which is going to contain all the virtual environments that we're going to create. And in my case, I have already created the one here, or with the name uh, with the name I think it was here in virtual env. I think bag, and we have this name, and then insert bin and then activate. One thing to note here is that this part of the path here and this part here is the name that you have to give. It's like a this like a placeholder for your virtual environment's name. So in my case, I've named it bagenv. So in your case, if you want to name it the same, then it should be like Python 3 minus m venv bag underscore in the end. So yeah, please remember to replace this placeholder with the actual name of your virtual environment. And once you have created it, you could simply source it using the folder which has all your virtual environments, then the name of your virtual environments, then the activate file which is present within the bin directory of your virtual environment, and we just source it. And after we do this particular command, we can see the name of a virtual environment in brackets in the command prompt. So this means that if you get this, it means that it's all good and fine. It's all been working well until now. And once we have set up the virtual environment, I think we could go back to this page again and then continue with our other dependencies. So the next dependency here seems to be Git. It is also pretty much straightforward to install. Go by saying sudo apt install Git. And yeah, it's already in the newest version for me. For you, could take some time to fetch and install. Once that's done, so here we need an Xscheme version which is greater than 3.4.4. So what we're gonna do now is we have a small appendix section here where we say the steps, or like where we have the recipe to install Xscheme. So it's very simple. First, we have some dependency packages as usual. Copy them, and we back here, and we just paste them. Again, for me, yeah, I just don't wanna lengthen the duration of this video by downloading all the stuff. So I have already did this part, so it could take some time for you again. Once this is done, we could clone this particular we can clone the Xscheme's Git repo by using this particular command. And here, like you see, it's currently we find that there is a regression issue with 3.4.4 version, which means that when you're cloning the repo, you can't build the Xscheme from the latest upstream branch or the master branch. So we first copied this line, and we okay, I just go to copy again. I'm gonna copy this and then paste this, and then after hitting enter, it should again clone the it should clone the Xscheme for you. And since I've already did this, I could after you do that command, you could do cd Xscheme, because once you run that command, an Xscheme directory would be created for you, which will contain which would contain all the source code for Xscheme. So if you see here, once you once you are in the directory of Xscheme, you have to check out this specific version, this specific commit of the master branch actually. So once you're in this particular directory, you should paste this command in your terminal. So we like copy this is a specific version which we have tested to work with the backend. And so we just go like git checkout and then the commit number. Yeah. So for me, it's already uh, currently at the same commit. So yeah, for you, once you uh, have this command, we all should be on the same page. And once that is done, we could say /configure. Figure. Okay, this is yeah, this should be quick enough. It should not be so tough to install Xscheme, to build Xscheme. This is going to check all if all the required resources are present to build the Xscheme. So if you have installed all the packages in the previous step, then it should be fine. So once you get a message like this, then we can go ahead and type sudo make install. Yeah, if it asks for your password, you could just enter that, and then it should start uh, compiling Xscheme from source. Okay, I'm just gonna pause this part because I think it's gonna take quite some time. Um, okay, yeah, it's done. Once that's done, we go back again to the Git repo page, and then yeah. So once this is done, we can go back again to the requirements section, and here we see that we'll be needing key layout. So the good part here is that we already have pre-built binaries of this particular key layout version, so we don't have to compile it ourselves. We just go on to Google and search key layout, and then get key layout for Ubuntu 22 in my case. And yeah, they're like pretty new versions as well, but this is what I have been uh, using quite a lot. So I'm gonna download this, but I already have it downloaded in my case, so I'm just gonna skip this part. But you could go ahead and download this particular dot dep file, and once that's done, if you could have a look into your file systems. If you're using subsystem for Linux, then it should be stored locally here. You could see the file here. It should probably be here if you when you downloaded it, and then you could copy this. And then there is this particular Ubuntu 22.04 file system, which is pretty easy to access if you're using WSL, so that you can just download it, download stuff on your Windex, and you could transfer it to these Linux's file system by just copy paste commands. So since I already copied that, I'm gonna traverse into the home, my username, and since here I'm gonna paste it. You could paste it, but yeah, I've already done that as well. Here you can see I have the .db file on my Ubuntu's home directory. And once this is done, we could shift back to our terminal and yeah, make sure that you're on your home. So if you are further, if you were in your xscheme directory, you could go something like cd space double dot to come back to your home directory, and then we just clear this stuff up. And now we could say something like sudo apt install dot slash k layout. You could just type k layout and then tab for auto completing the file's name. And once you have this thing done, you could press enter. Yeah, this is going to install k layout from this Debian package. And just to make sure it works, it'd be like k layout -v, and that should print the version of the k layout installed. So okay, so we are also done with this right now, and we can go back to our page again here. So yeah, for now, we can ignore ngSpice 41 because this is primarily used for simulation, and the the simulation setup for batch generators is currently a work in progress. So yeah, once it's finished, we could have a follow-up video for that. So no, we can ignore that. So moving ahead, we need to install some Python packages. So we just like copy this command, go back to our shell, make sure we are in the virtual environment, and then we just paste it. And here, an important point to note here is the version of Volar, which we realized recently that one of the latest version uh, fails to work. Uh, so it was causing some issues. So I would suggest we stick to this particular version of Volar. So to specify that, we just say Volar equals 0.11.3, and once we do this, it should again fetch different stuff and it should install it in your virtual environment. For me, it's already done. For you, it could take a bit more of time again. So I'm just going to clear this. And now if we shift back here, now it's time to set up the PDK. So what we're going to do now is copy line by line or in this particular code block. So first we set up the PDK root environment variable to this particular path, which is your home directory / PDK. And then we export the variable pointing to the specific PDK variety within Sky that we would prefer. So basically there are like two varieties, which is Sky 130A and Sky 130B. So we're going to stick with Sky 130A. And then this part is for K layout to find these files. And then finally, we also make the directory. In my case, it's created, so it's gonna throw an error. So yeah, for your case, you should create a new directory here, like PDK. Yeah. Once this is done, uh, we can use the Volar to list all the available PDK versions and to list all the available pre-built PDK versions using this command. So we just copy it from there and again paste this. When we hit enter, yeah, so it gives you all these different varieties of all these different versions of PDK builds. So yeah, you should probably copy this particular the first entry in this particular list. Since I've already did that, I'm just gonna copy the second one. I mean, I already have it installed and enabled. So just for example, I'm going to copy the second one. You could copy the first one, and I think I have to shift copy. Yeah, and now we come back here to this particular README page. Uh, we can see this command here: volar enable --minus pdk sky 130, and then the dollar chosen PDK version. So this is so instead of this chosen PDK version, you would be needing to paste uh, the commit number that we just copied. So we just from this code block, we just copy this part which is highlighted here. We shift to the terminal. We paste. Okay, I'm just going to clear this. And now paste this. And then space, Control V. Okay, I think just a moment. I'm just gonna copy this and paste it. I'm copying this one. I'm gonna paste this. Yeah, you could paste it as well. And then copy this particular path here, this particular command here until sky 130. Go back again, paste it here. Sure to have space here. So yeah, once we enter, this is, as you could see, it's gonna download a lot of files. It's gonna take pretty much time, and yeah, I'm gonna stop it for now. But let's say for me, I've already installed it. So once you finish running this command, and once you run after you have executed the command below, if you run this command again, um, you should see something like the latest version and enabled. I mean, in brackets, you should have enabled here. So that shows that the step has been completed properly. And once that is done, we could, yeah, we can again ignore this part for now. Go to the extreme case that it's not actually required. And now we could, I think, set up the PDK for K-layout. So there's one small change that we been doing with the K-layout tool. So we just typed K-layout and enter. And yeah, I mean, this is fine. I'm just gonna show this dialog box. Okay. And then if you see here, I'm not sure if you could see, but you would be having a separate window of Kiliot opened up for you in your in your taskbar. So open this thing up, and now we make sure to go to Tools, Manage Technologies, Close, and then here Sky 130, and not sure why this is not working. Okay, but anyways, um, then select General, and here in your case, it should look something like this: sky130.lyp. But what it should actually be is sky130a.lyp, because for some reason the variant is not specified by default when the K layout is looking for all the PDK related stuff. So yeah, this is just a small tiny fix that we have to make. So yeah, again, make sure based on what variety you have chosen. If it was B, then it should be B here, and if it was A, it's A. And since we have already chosen the PDK variety while setting the environment variable to be sky130a, I'm just gonna let it stick to sky130a.lyp. Once you're done, you could press OK, and then close this. With that done, uh, we could yeah, this all was about that. And now we could again set up so now it's time for us to set up the workspace, which is nothing but the git report on which we are currently. So from here we could copy this particular line, which clones using the HTTPS protocol. Just like copy and Control V. And once you did that, you could just hit enter. But for me, again, I have already uh, cloned this. So if you see my directory, you could see the open source DB template here. So once you run this command, it's going to fetch some stuff. And once that's done, you're going to have a folder in your home directory which goes by the name open source DB template. And once that's done, you could change directory open source DB template. And once you're in here, you could, yeah, first init the submodules. Um, you could be like dot slash init underscore submodules dot sh. Yeah, this is working fine. And once that's done, you should also make sure you have the additional web packages installed as well. So for doing that, there's this small handy script that we have, which is pip3 user install.sh. So once you click this, once you type this and hit enter, it's going to install all the different packages. And you could see here, for me, it's again already satisfied. So I'm just going to stop this right away. So once that step is done for you, I think we are good to go ahead and source the startup file. So you should be like source space source me dot sh, and this would also do a check as to whether if you have the correct versions of K-layout and Xscheme installed. So I think if you have some deprecated versions installed, then this would highlight that this is not going to work. So you have to change the version otherwise. But yeah, um, once that is done, I think we are good enough to run our very first generator, which is the basic inverter one gen. So the command for running all these generators, we have this handy Python code, which we call as the gen tool. And to invoke it, we say gen. And after that, it has a lot of sub commands, which you could see by typing minus minus help. And out of these sub commands, we are going to use the make sub command to create the generator by create the layout and schematic updation. And once that's done, it's also gonna do the LVS. So the gen make is gonna make the generator and also perform LVS on it by default. There are also separate commands like LVS and DRC, which you could execute to perform those specific checks on your generator layout or schematic. So now we are gonna go like gen make inverter one underscore gen, and then this should pretty much get it all working. And as you see here, first generates the layout and then make sure to implement the schematic. And once that's done, it's going to check for LVS, and you see here we have the LVS succeeded. And we could also, in a very similar way, perform the DRC check for gen. say gen drc and the generator's name, which is inverter one underscore gen. So this is gonna do that as well. And now this is done. If you could see your directory, you could have the GDS file generated here. So this is the GDS file which is generated by the bag. So it's directly on your root directory of your project. And to have a look at the schematic updated file, the schematic file which is updated, you could go to the generated sky 130 FDPR folder, which is this one. And then if you do here, again, the cell name, yeah, here you have the implemented schematic and the symbol. So these are the folders where the bag saves its output. And there is also this another folder called K-layout run. So if I could just quickly go back uh, into K-layout run. So whenever we do the LVS or DRC, K-layout is a tool that the open source flow uses to perform on these checks. And when doing that, for each check, there is a report file generated, and those report files could be found here in this K-layout run directory. So if you do a there again, yeah, you have LVS run there and DRC run there. So based on which report file you would like to view, you could just, let's say for now, I'd like to see the DRC report. Go in there again, search CD inverter, check again the cell name, and hopefully here we should have it. Yeah. So here you see that you have this lyrdb file is the report database file that I was talking about. For DRC reports, the extension is of one kind, and for LBS reports, it's of another kind. I mean, the extension is different. So, so yeah, so you can also find the log file and the DRC wrapper scripts here, which just for debugging purposes, it's a bit helpful. So similarly, you could also view the report files generated during an LBS check. And if you don't want to do this hard way of traversing through directories, there is also another very helpful command, which is something like so you say, let's say you want to do an DRC check, and then if you want to open so there is a switch so the switch here which is called G, which stands for show GUI, and it has basically three options: never, uh, always, and on error. So if you set the switch to always, no matter whether you have some DRC errors or if you don't have any files, the report file is always going to open. And if you put it on error, like uh, it's straightforward. If you have any errors, it's just going to open the file for you. So by default, it's on error. The -G switch is set to open only on error, is set to show GUIs only on error. So by setting it on always, we can run the DRC again just to show you guys how this feature works. Uh, yeah. Yeah. So once this is done, you could see it automatically opens the report GUI. And yeah, on this tab here, you could see your layout. And yeah, if you see something of this, uh, yeah, you should also always make sure to switch to the Sky 130 technology and click on it to use uh, the layer property files of that particular PDK. And yeah, so always switch to Sky 130 and also click on this thing to apply it. So this here is the one that I could do this here, and also this window here shows the marker database. So this is the report file, and you could see here all the different DRC rules which are encoded or which are checked, and we see that all of them are green, which means that all the DRC rules is satisfied. The same applies even for LVS. Just the format is a bit different, and the way it looks is a bit different. And now we have successfully ran our very first generator, which is the inverter 1 gen. So if you see this particular, all the generators are with the specific name scheme, which is like the name underscore gen. So when you see a folder like this, it means that it has the source information of a generator. So, and each of these generators is again a Git repo. So if you could see here in the Mosaic bag, we have this repo here called, we have a sub project called generators, and within that we have the two-stage op-amp. So this is the one that we are currently trying to port to Sky 130 technology. It was originally made for TSMC 28 nanometer technology, and yeah, so this is uh, the sub project which has all these generators related to stage op amp. To install them, you could again use this uh, uh, feature of Gentool called add uh, all of, I guess, and then the mosaic op amp. So on running this command, it should clone the Git repos and make all the necessary changes for the framework to recognize all these generators and also execute them. So as you could see, it's cloning a lot of Git repos because PAM depends on like almost like 10 to 12 different generators. So once this is done, if I again do dir, you could see there are various different directories that end with underscore gen uh, in their name. So each of this, and also to know what packages are available to download, like how we like to fetch and install, you could use the gen avail command, and these command is gonna show you. So these are the different generator groups. So mosaic is a default one. So mosaic pamp is the one which I just installed, and this is the mosaic test bench. So this is this is something which is work in progress still. So so yeah, we have installed all of this, and way to run this is very much similar to what we did before. So we again, let's say we want to make mux 2 to 1 gen. So we say gen make mux 2 to 1 gen, and this is going to generate the mux for us. See, the layout is instantiated, and yeah, it's it's finished implementing the schematic. LBS is gonna take some time usually, but yeah, it's done. A similar way, we could also run the RC, and this time let's also open the report files that have a look at the layout. Uh, okay, just taking some time. Okay, the RC is succeeded and the GUI is open for us. Close this. Again, you could see the categories, all of them are green. Close this thing up, and here you could see uh, this is the generated layout of Mux 221. And if you also notice, yeah, these are made out of inverter 2 generator and also the T-gate generator, which are like the leaf generators. And this Mux 2 to 1 is like a hierarchical generator, which depends on uh, a couple of other generators, which is like in this case inverter 2 and T-gate. And so I think, yeah, those are the basics to start on with. They're like not so out of all these available generators, I think most of them should work, except for, I mean, currently, except for the top gen and full chip gen, and also the buffer gen. Rest all seems to work. So you could go ahead and try running all of them. And I think, yeah, that would mark end of this video. Um, I think it was, hopefully it's not a lot too much information at one go. Yeah, and if you face any difficulties, please feel free to reach out to us. Yeah, and yeah, thank you for your attention, and yeah, until next time, bye bye.